let's begin with our new topic, that is projection of solids. That is your last unit from the syllabus. Rest 1, 2, 3 we have covered. This is from my side, it will be last, and unit 5 it will be from your side. Okay, so let's begin. I will try to finish the theory part, and some of the drawings also we will see. So projection of solids. In this topic, what we will see uh, when solids are projected on your horizontal plane or vertical plane, so how they will be drawn on 2D drawings, how their projections are drawn. So that we will see. So before starting with the projection of solid, first we have to understand what is solid, what are the different types of solid that we consider in engineering drawing. So as you can see on your screen, that basically the solids are divided into two main groups, polyhedra and solid of revolution. So one by one we will see what is polyhedra. Polyhedra is defined as a solid bounded by planes called faces, which meets in a straight line called edges. Okay, so we will see the diagram. With the diagram, we will be able to understand what is this polyhedra is. In polyhedra, we will see prism and pyramid. So let's see prism. This is your prism. As in the previous slide, you have seen that I told you the definition that polyhedra is a solid bounded by planes called as faces. So here I will highlight this. This is your faces, side faces, rectangular faces. This is a triangular prism because you can see at the top and at the bottom you have one triangle. So and on the vertical side you have rectangles. So rectangular faces, they are coming and they are joining these parallel surfaces at the top and bottom. So at the top you can see this is your one triangle, and at the same time you have at the bottom also one triangle is there. So you can see that these two triangles are parallel to each other. Okay, and their vertices, these are the vertices, their vertices are joined with these lines, and these lines are forming one rectangle in your vertical plane. So that is what we have seen in your previous slide, that a polyhedra is defined as a solid bounded by planes called as faces, which meets in a straight line called edges. So here your edges are there, these lines. Okay, so in polyhedra, we have seen two categories, prism and pyramid. So in prism, what you will see, prism is a polyhedra having two equal and similar faces. Okay, here at the top and at the bottom, you can see triangles are there. So they are equal in nature, they are similar faces, called its end or bases, parallel to each other and joined by other faces which are rectangles. So that I have already shown you in the figure. And the imaginary line, the imaginary line which is joining these two center points, which is joining these two center points, this is called as the axis of your prism. Just 1 minute, excuse me. Okay, so here we have seen that two equal and similar faces are joined with these rectangles. Okay, and at the top and at the bottom, this if the center points are connected, so the line joining these two center points are called as the axis of prism. This you keep in your mind, because when we will be doing the problems or drawings based on that, then axis length will be given, or information regarding the top face, whether it is a triangle, a square, or pentagon, or hexagon. That information will be given. Based on that, we will draw that prism or pyramid. So now on your screen you can see certain examples of different shapes of the prisms are given. Like according to the shape of the base, prism can be sub-classified into following types. So this is your triangular prism, just based on the top surface geometry, whether it is a triangle or whether it is a square. Okay, these prisms are classified. This is your pentagonal prism, because on the top you can see there is one pentagon, and same exactly you can see at the bottom also there is one pentagon. Okay, and the line joining these two center points is called as the axis of the prism. Okay, and this is your hexagonal prism. So you all know that pentagon is having 5 sides, hexagon is having 6 sides. So based on that number of sides, these prisms are classified. Now coming to the next type of your polyhedra solids. So these questions can be asked in your normally asked in your viva examinations. Okay, like what do you mean by polyhedra solid? What is the difference between prism and pyramid? Okay, so these things you should be able to answer it. So now coming to pyramid. Now what is the difference here in this figure and the one that you have seen in this figure? Here you can see those two parallel faces are connected with rectangular faces, but here you have one face at the bottom. Let me take some other color. Yeah, here you have any geometry at the bottom, and all these vertices are connected at the top. One point is there, and that point is called as the apex, or also called as the vertex. And the perpendicular line joining from this vertex to the center point of the base, you can see one center line here. So that is called as the axis of pyramid. Okay, this is the axis of pyramid. So let's see what is the definition written here. Pyramid is a polyhedra having plane surface as a base and a number of triangular faces. So here you have triangular faces. Earlier we are having those joining figures as rectangle, but here you have triangular faces. So these triangular faces are connected at one point, that is called as your apex, or also called as vertex. Okay. So the imaginary line joining the apex with the center of the base is called as your axis of the pyramid. Now, based on the geometry of the base, you can see the classification of pyramid. This is called as your triangular pyramid. Here at the base, you have one square. So this is square pyramid. Here at the base, you can see one pentagon. Pentagon means 5 sides. So this is your pentagonal pyramid, and this is your hexagonal pyramid, because here you have 6 sides at the base. And you can see here the hidden lines are shown by hidden lines, dash lines, and the line joining the vertex or apex to the center of the base is called as your axis of the solid. So these are all your polyhedra solids that we have seen here, polyhedra. Now we will see solids of revolution. Now, did we have discussed these things in the previous lecture? I can see those annotations on my slide. So this is the solid of revolution. Here, when a solid is generated by revolution of a plane figure about a fixed line, then such solid are named as solid of revolution. Like you can see in figure number 1 here, I have drawn a triangle and one axis line I have drawn. Okay, so if I will revolve this triangle about this axis, then you will be able to get this cone. Okay, if you make a rectangle like you can see in figure number 2, and then you will revolve it about one axis, then you will get a cylinder. If you will make a semicircle like you can see in figure number 3, and you revolve it about one axis, then you will get one sphere. So this type of solids are called as solid of revolution. When a solid is generated by revolution of a plane figure like in figure 1 we have seen this triangle, in figure 2 you have seen that plane figure as rectangle, and figure 3 you have a semicircle about a fixed line. Fixed line is your axis. Then such solids are named as solids of revolution. Okay, so these are the types of solids of revolution like cylinders and cones. Now, a right circular cylinder is a solid generated by revolution of a rectangle about its vertical side which remains fixed. Suppose this is your axis line, you can see at the center. So if this is your one rectangle, suppose, and if you rotate this rectangle about this axis line, then you will get this cylinder. And these two circles, one at the bottom and one at the top, okay, these two circles you can see, these are called as the base of the cylinder. And these vertical lines you can see, vertical lines, let me show it in red color. These vertical lines are called as generators. These vertical lines that you can see on your screen, these are called as generators of this cylinder. Okay, likewise you can see it for your cone also. This is the base circle, and the line joining these vertex to the center of this base is called as your axis of this cone, and remaining these slant lines that you can see here, they are called as the generator of a cone. Because suppose you have one triangle over here, you have one triangle over here. If you revolve this triangle about the axis, then you will get this right angled triangle cone. Okay, so this is about your cone. Now generators. What are those generators that I have already explained to you? For pyramid and prism, edges are the lines separating the triangular faces or the rectangular faces from each other. For cylinders, generators are the straight lines joining different points on the circumference of the base with each other, like I have shown you here in the red color. Apex, already I have explained you what is your apex, edge, generator. These things I have already explained you. So here once again, those things are mentioned for cylinder and prism. Now suppose if I'll ask you to draw this triangular prism, can you draw it in your AutoCAD?
Yes, sir.
Okay, now this unit is very simple. So in this we have to draw these cone cylinders, their top view and front view. So you tell me about this cone. If you, I will ask you to draw the front view of this cone. Can you draw it? What will be the front view of this cone? Can anyone tell me? Very simple.
Triangle, sir.
A triangle you will get. Suppose one XY line I have drawn over here. So front view, you will get a triangle like this. And in top view, you will get one circle. And the apex will be at the center of this circle. And you have these generators, you can draw to show that this is a cone. Okay, so this is how the projections of a cone will be drawn. Similarly, if you want to draw for this cylinder in front view, what you will get?
Rectangle, sir.
Yes, in front view you will get one rectangle, and on top view you will get a
Triangle.
circle. And in circle, these generators you can draw. And you may not draw because may or may not draw, because here if you are drawing those generators, then you can draw their projection over here. If you are not drawing those generators, then no need to draw those things. Okay, so like that.
Sir,
Yes.
uh, sir, we can even copy this, na, sir. Means we can draw one triangle and then copy it from other sides so that it will be easy to draw.
I did not understand what you are saying.
Yeah, sir. We can even copy it, na, sir.
From where?
Means that shape of
Yes, when we will be doing this in your AutoCAD, so it will look like this. I will show you here. In this unit, you have to draw these drawings where the projection of this cone, this cylinder, then you have these two figures are your solid of revolution. So this is cylinder and this is cone. Now coming to prism. Prism, you can see at the top and at the bottom there are parallel faces. So this is your square prism and this is your pentagonal prism. Okay, so how you will distinguish between a prism and pyramid? If this is a pyramid, it will come like this. So here you have a single vertex. Okay, so this is the apex of the pyramid that you have seen, and you all people know about those pyramids of the Egypt. Okay, you have seen so many places on internet. So this is a hexagonal prism pyramid, and this is your square pyramid. So at the base there is your square is there, and all the vertices are connecting at this vertex point. So these six figures, solid of revolution, this is polyhedra prism, this is polyhedra pyramid, and then one drawing we will see how to draw the projection of a pentagonal prism. Okay, of base side is 25 and its axis length is given 50 units. So when it is, see the condition, these are the basic dimensions. With those basic dimensions, you can draw the geometry like this, that it is resting on a horizontal plane. Okay, that we will discuss right now. But here you need to pay attention. When it is resting on one of its rectangular face on the horizontal plane, the axis, So in first figure, suppose this figure I will divide in two parts. This is your first part and this is your second part. So in first part, you can see that the cylinder, this pentagonal prism is resting on your horizontal plane on one of its rectangular face on HP. Okay, so this face you can see, I will draw that face on which it is resting on horizontal plane. Yes, so B1, C1, 3 and 2. So this rectangular face, on this rectangular face, your pentagonal prism is resting on your HP. Now, after this, what is the next part of this question? The axis of solid is inclined at 45 degree to the vertical plane. Now, here you can see this axis is making, this is your axis, is making 45 degree with your vertical plane. Okay, so normally what we do when this angle is given that 45 degree to vertical plane, then we come below this reference line. If it is written like the axis is inclined 45 degree with horizontal plane or 60 degree with horizontal plane, then you have to draw that 60 degree above your reference line, then this will be your 60 degree, like that you have to draw. Okay, so here what we did, we have drawn the object in simple position. Okay, and then we have rotated this component by an angle of 45 degree. Once you do this, thereafter we need to draw the projection to get the 3D view of this pentagonal prism. So when we will be doing this problem, I will elaborate this in detail. So first, let us see what are the questions that we have to solve here in this unit. So these are the questions. Draw the projection of a cone and cylinder resting on horizontal plane. I hope you all recall the concept of horizontal plane and vertical plane. Is this in your mind, or do I need to explain it once again? Horizontal plane and vertical plane concept, the things that we have seen here, just I will show you, that will come to your mind. Yeah, this is your horizontal plane. Suppose one cylinder is placed on this horizontal plane. Okay, so if you will draw the projections, the rectangle will come over here and that circle will be coming to your below xy line, if this is your xy line. And then we used to open this in this direction and this in this direction. So you will get a rectangle above xy and a circle below xy, like that we have drawn over here. Yeah, this figure. So in this question, it is written that same thing, that draw the projection of a cone and cylinder resting on horizontal plane having 20 base radius and 70 as your height. So height is 70 So that is what I have drawn it over here. And the radius is 20. So diameter will become 40. Similarly, the same will be there for your cone also. Only difference will be there about this vertex point. So these corner points will get connected to this vertex point. So this is the only difference that we will see here. Okay. Okay, one student has posted one message. Sir, keep this PPT in Canvas. Yes, I will upload it. I will upload this PPT also in your canvas. Okay, so now the time is 11:50. We will take a short break of 10 minutes. Then again we will start by 12 o'clock. So by that time, you can stay here muted. I will also mute myself and we will start the class again by 12 o'clock. Don't leave the meeting.
Sir.
So, okay, students, we have now 34 participants. Okay. So we were discussing about the cone and cylinder was over, and after that, let's see the question. That is your second question. Uh, I hope you all are here. So now draw the projection of a square prism. Here the question is you have to draw for a square prism. So this thing you have to keep in your mind that it is a square and it is a prism. Okay. And prism means two parallel faces you have to keep on the top and at the bottom also. It is resting on horizontal plane. Okay, it is resting on horizontal plane on one of its base. The base edge is 20 mm and the height of this solid is 70 mm, and one of its base is perpendicular to the vertical plane. Okay, one of its base edge is perpendicular to the vertical plane. So how it will look like, then we will see. As I told you earlier also, whenever any information is given related to your vertical plane, okay, then we will uh, allocate that information below your reference line. Suppose this is your x y reference line is there. Okay, and here it is saying that you have some square prism, it is resting on HP. So first thing is clear that there will be some square. If it is resting on HP, then in your top view you will be able to see one square. Okay, and on the front view you will be able to see some rectangle like this. Now the next part of the question, the dimensions are given. Okay, that is also fine. Now next what is given is one of its base edge is perpendicular to the vertical plane. So that we have already seen here. This is perpendicular to your, this is perpendicular to your vertical plane. Okay, this angle is 90 degree. So that is also incorporated in this part. So for that you can see this drawing. In the top view you have to draw one rectangle as you can see here, and the two corners, one will be at the top, see here, 4 1, they are coming in the front side, 2 prime and 3 prime. Now question must be coming, why I have used this prime, 1 prime or 4 prime. So vertex is represented in top view as either you can use some alphabet or some numbers to represent the corners. So in top view, if you are doing like D, A, B, C, and D, these are the 4 base corners, and 1, 2, 3, and 4, they are the top corners of the square on the top face. Okay, so if you are representing it like this in top view, then the nomenclature you have to modify in your front view. So we used to make A as A prime, D as D prime. Okay, 1 will become 1 prime and 4 will become 4 prime. If you are drawing the side view of this component also, then in side view that will be represented by double prime. 1 double prime will come into picture, like 1, 2 dashes will come here like this, 2 double prime will come over here in your side view representation. So here we are not going into the side view, we will draw only front view and top view. So this is the explanation for your question number 2. Now question number 3. Draw the projection of a pentagonal prism. See, you have to underline what are the information that you have to keep in your mind. The projection of a pentagonal prism. So This is pentagon, means it must be having 5 sides. It is a prism, so the top face and the bottom face, they must be parallel to each other. Okay, and its base dimension is given 20 mm and height is given 70 mm, resting on horizontal plane. Okay, so again, um, since it is resting on a horizontal plane, so pentagon will be coming just below this xy line about its base, and one of the base edge is perpendicular to vertical plane. Suppose you can draw pentagon like in two orientations. Let me see if I have here ready-made pentagon. Yeah, here I do have. I will suppose in top view you can draw one pentagon like this. You can also draw this same pentagon in this orientation also. Okay, suppose this is a prism, so in your top view you will see this component like this. Now I will draw the xy line, that is your reference line. So in top view, there can be two orientations in which this pentagon can lie. Okay, so that's why you can see here the condition what it is written. One of the base edge is perpendicular to the vertical plane. So here you can see this edge is perpendicular to your, this is perpendicular to your vertical plane. Okay, so this will be the orientation that we will keep here. This is correct. We will not keep this one. Okay, if it in the question it is written like one of the base parallel to vertical plane, then you can see here this edge is parallel to this vertical plane. In that situation you can keep this as your orientation. Okay, so these are the two orientations where you can keep your pentagon. So now likewise you can draw your projection lines from here, and then you can draw the front view also in the same manner. Okay, so this is regarding your pentagonal prism. Here again two faces are there. So the top faces are named as 1, 2, 3, 4, 5. These are your corner points or vertices, and the bottom face is represented by A, B, C, D, E. Okay, so here you can see A prime, E prime, and C prime. At this location, B prime and D prime will come. Here it is missed, so I will write D prime, comma, B prime also. Okay, so at this corner it will be like that, and this vertex O and O1. So O is there on the top face, the center of the top face, and O1 is the center at the bottom face. So that you can see here in your top view. So this is the explanation for your question number 3. Now question number 4, I will show you. Draw the projection of a hexagonal. Here the term to be highlighted is hexagonal, and it is a pyramid. Its dimension is given 20 mm is your base edge, and the height of this pyramid is 70 mm. It is again resting on your horizontal plane. So again here in your top view, one hexagon you have to draw. So let me see, do I have here hexagon ready-made? Yeah, I do have. So you can draw a hexagon like this. Now, what is the other condition that is given that you have to check? About its base, and one of the base edge is perpendicular to vertical plane. If it is written like this, then you have to change the orientation. Suppose this is your XY line or the reference line. I'm talking about your top view only. This is your reference line XY. So in that situation, the question is saying that the base edge is perpendicular to the vertical plane. So you can keep the orientation like this. Then you can see that this edge and this edge, they both are perpendicular to your reference line. So this will satisfy the condition of the question. So now you can see here how it will be drawn. Since this is a pyramid, so first you have to draw a hexagon and you have to connect all the vertices at center. O is the center of the base hexagon, and O1 is the vertex at the top location at a height of 70 mm, because the axis height of this pyramid is given as 70. Now the corners are represented as A, B, C, D, E and F. Okay, so you can see their projections in front view as well, A prime, F prime. This yellow color line is representing your projection lines. Okay, and at this position, this center position, at this position, you can see E prime, B prime, O prime. This projection of E, O, O1 and B. So O1 is your vertex, so it is coming at the top. Rest E, B and O, it will be coming to this point. Okay. Similarly here C and D, they will be coming to this location, C prime and D prime. So likewise you have to give the nomenclature also. Now one, draw the projection of a square pyramid. Question number 5. Draw the projection of a square pyramid. Let me highlight, or first let me clear this. Do I have any option for doing that? Let me check. Okay. Okay, one by one I have to select them and then I can delete these things. Okay. I will insert a blank page. That will be good. Okay. Now let's discuss on this question number 5. You have to draw the projection of a square pyramid. So for C, this is a square and this is a pyramid resting on horizontal plane about its base. So it is resting on horizontal plane. So you can draw one reference line, X and Y. This will be our reference line. Since this is a square, so I will take a square from here. Yeah. Now again, you can see the orientation of this square can be different. You can keep in any orientation. It can be parallel like this. It can be, okay, both will be same because this is a square. Here it is parallel also, their bases, and these faces, let me use the annotation. Here you can see this edge is perpendicular to your VP and this face is parallel to your VP. But let us check what is given in this problem. What is the condition? The square pyramid is resting on horizontal plane about its base in such a way that all the edges are equally inclined to the vertical plane. So here in this figure you can see this two edges are equally inclined to your vertical plane. So if you will extend it, you can see this is equally inclined. These two angles will remain the same. So this is the orientation that is asked in this question, and the dimensions are given. Height is 70 and base length is 20 mm. So the drawing will be like this. Below your reference line, this is your X, this is your XY. Okay, so square you have to draw on your top view. Okay, since this is a pyramid, so it will be ABCD, one square at the base like this, and all the corner points will be joined at a common center point O and O1. So O is the center for this base and O1 is the vertex. Okay, so this is how these figures can be drawn. I have explained all the 5 figures that you have to draw in this unit. There is one more figure, this one. So here a pentagonal prism is there, its dimensions are given, and there it is resting on one of its rectangular face that I have already explained you. It is resting on this face on HP and it is inclined to 45 degree. So you have to draw this first phase of the drawing, and what you have to do, you have to reorient this top view. You have to rotate this top view at an angle of 45 degree or whatever the angle is given at this location, since it is making angle with VP. So you rotate that component and then you draw the projectors from the top view and the front view, and the point of intersection you have to find out to get this 3D image. So before explaining you, I have one animated video also for the explanation of this figure. So let's see this. Very easy because it just had very easy. Yeah, this one is very easy because it just had one. Let us make this problem a little more challenging by taking up two steps. This problem, for which the problem statement is now here, the pentagonal prism is the same with 30 mm of base and diagonal 60 mm. It has rectangular face with image views. This is what makes it change. The axis of it is inclined at 60 degrees to VP, and you have to draw it. So once again, let us take down the given data from the question. First, the question is telling us that a rectangular face is in HP. Next, it says that the axis of it is inclined at 60 degrees. So here in this question, the inclination with vertical plane is 60 degree. In this question, it is 45 degree. So that is the difference. But the process will remain the same. So just see how it is drawn. The axis of it is inclined at 60 degrees to VP, and you have to draw it. So once again, let us take down the given data from the question. First, the question is telling us that a rectangular face is in HP. Next, it says that the axis of it is inclined at 60 degrees to VP. So this inputs should translate to us like this. First, the first given data should tell us that the pentagon should be drawn with an edge on XY. After completing the pentagon, we should continue to take its top view. Then the second point, the axis being 60 degrees to VP, should translate to us to mean that we have to redraw the top view at 60 degrees. After the top view, again we have to the final point. Let us proceed to draw the diagram. Once again, we have to draw the XY line, right VP just above the XY line, and HP just below it. Front view, of course, appear above XY, and top view below XY lines. The next step, this is where we have to start drawing the pentagon. So first,
As we had seen in the given data, first of the edges should appear on a skyline. Right, exactly on a skyline, and proceed to complete our pentagon. Once we have found the pentagon, the next step is to project it to get. We have to draw vertical lines from all the vertex points, and then we get the outermost boundary and identify all the vertex points exactly. Yeah. Having completed these two steps, the next step is to identify the inner visible edge. Looking from the opposite side, we see that the edge E is coming first, and hence that edge is visible. The remaining two edges, the one from B and C, are behind the figure.
Here in the top view, you can see uh, someone's mic is unmuted. Mute yourself. Yeah. Here in the top view, you can see the line number connecting this point B and 2. If you will see this pentagonal prism from the top, this B and 2 will not be visible in the top view. Similarly, this C and 3, if you will see this pentagonal prism from the top, okay, then this C3 will also be not visible. So these are represented by your hidden lines or dash lines.
To be drawn as hidden with that. That's it. This is the first temporary view. The next step is to get the second temporary view. In the second temporary view, we have been notified that the axis of the prism is inclined at 60 degrees to the equilateral. So we have to draw this top view. We have to actually redraw this top view. That means we have to get a Xerox copy exactly as it is of the top view that we got in the first step and redraw it such that its axis is inclined at 60 degrees. So we have got this first edge E5 then inclined at 60 degrees. So using this, we have to again get all the other vertex points exactly as we have got in the previous step. Once you have got all vertex points and you have copied the diagram as it is in 60 degrees, the next step is to get the
Simply, we have rotated this drawing at an angle of 60 degree. So you can simply select the components and use your rotate command in your AutoCAD so that you can get this type of figure. When we were drawing the figure using pencil and your drawing sheets, then manually you have to draw all those lines like this at an angle of 60 degree.
Sir, if you use polar means
Yes,
polar coordinate system.
yes, you can use it. You can use polar coordinate systems wherever you can use it. That is a tool given to you, whether you use polar coordinate system, you can use your Cartesian coordinate system, but for Cartesian, your coordinates are required to be known. If you are working with angle and length, then you can go for polar coordinate system, as we will use in drawing these figures. I will show you after the explanation of this video. We will start drawing these 6 figures in your AutoCAD.
one by one draw the projector lines and match them with the projector lines of the previous one to get all the 10 vertex points of this front. After getting all the vertex points of this front view, we have to go to the next step.
So see here, all the lines are vertically projected from the second part. They all are projected in vertical direction, and the projections are coming from this front view also. And the point of intersection, see here, A from this point, oh, that disappeared. You can, oh, as I am clicking on this annotation, that video is disappearing. Okay.
So in the front view, all the edges.
So you can see this A is going the projection line from here and the A is coming from this direction. It is intersecting at this location. So here you are having A prime. Now same, B is going from here in vertical direction. B is there in this horizontal line. So the point of intersection, you are getting your B prime. Similarly, this E will be going from here, and E is over here. So it is intersecting at this location. So your E prime will be at this location. Similarly, for the case of D prime also, D is going from this side and D is there. So the point of intersection of this horizontal and this vertical will give you the projection of that point. Similarly, 1, 2, 3, 4, 5, these points are also projected. See, this 4 is going from this point in vertical direction, and 4, the horizontal line from this 4 is coming like this. So the point of intersection of this horizontal and vertical projection lines will give you the projection of this 4 prime. In the same way, this 3 and this 3, this 5 is going here and 5 is coming here. This 2 and 2 is here. So it will come like this. So this is the way how the projection of these lines are drawn. So let's see the later part of the video.
Boundary. After
So you can join all those boundary points. The boundary points will all be visible. Now you have to identify, if you are looking this prism from this side, what lines will be visible and what lines it will not be visible. That is going to be explained in this part of the video. Let's see it.
completing the outermost boundary, now we have to view from the opposite side to identify which of the inner edges will be visible. So in this diagram, we see that the point which first comes is point 1. So in the front view, all the edges which are coming from the vertex 1 should be visible. Remain all the edges should be hidden, hence have to be drawn as.
So you can see that prism how it will looks like. E, D and DC, they will not be visible. Similarly, D and 4, line connecting this D and 4, that will also be not visible from this side. So they are made as hidden lines.
That's it. That completes our.
So this is for this inclined plane. When the object is in inclined position, what you have seen in these three slides, first slide, second slide and third slide, here the axis is parallel or perpendicular to your horizontal and vertical plane, these 6 figures, whereas in this figure the axis is inclined to any one of the plane. So for this case it is vertical plane. So I have here one more video. I guess this is also related to this inclined problem kind of thing. So let's see.
Hi, this is Srikant from the Academy of Postpartum by. Here I am. Next part of the video, which we will see the projection of solids to the pentagonal prism. In the last video, we saw how to draw a pentagon and what is a pentagonal prism, and also we saw the rules to be followed for getting a projected view of the pentagonal prism. In this one, we will take up simple problem to actually implement all these rules. So this is our problem statement. A pentagonal prism of base side 30 mm and axis height 60 mm is resting with its base in the. Draw its projections when one of its edges is at 30 degrees to HP and the second bit is at 60 degrees. So let us jot down the given data and try to see what we should analyze. The only given data which is of value to us is where is that the base rests on. This should translate to us in telling us that draw the front view above xy. So we should draw the front view above xy, and the pentagon actually appears in the front view, which is to be drawn above xy. Then, after drawing the front view, we should get its top view with projections. So let us move ahead and see what are the steps to be taken and how to draw the pentagonal prism. The first thing we need to do is to draw the XY lines, and we should write VP just above the XY line on the right side and HB just below it. It is customary to understand that front views appear above XY while the top view appears below XY. That's what happens when we draw the view in the first angle. Okay, so let us move ahead and draw the pentagon first. We have to draw the pentagon above XY. That's what we understood from the given data. So the inclination of the first edge has been given as 30 degrees. So we have to draw the first edge at 30 degrees and continue to follow the steps to be taken to draw the pentagon, get all the five sides. Once we have got all the five vertices, we have to project them.
So here in this problem, if you will pay attention, in the question it was saying that the pentagonal prism of base side 30 axis is resting with its base on vertical plane. Okay, so this time, uh, if you are able to imagine, this is your vertical plane and this is your horizontal plane. This time the object is placed with its base on this vertical plane. Okay, and further one more condition is given, that one of its edge is making an angle of 30 degree for the first case and 60 degree for the second case with your HP. So 30 degree with one of its edge is making 30 degree with HP and 60 degree with HP. So that's why this time that pentagon we have to draw above your reference line.
Below it. It is customary to understand that front views appear above XY while top views appear below XY. That's what happens when we draw the view in the first angle. Okay, so let us move ahead and draw the pentagon first. We have to draw the pentagon above XY. That's what we understood from the given data. So the inclination of the first edge has been given as 30 degrees. So we have to draw the first edge at 30 degrees and continue to follow the steps to be taken to draw the pentagon, get all the five sides. Once we have got all the five vertices, we have to project them downwards to get its top. These lines are called projector lines. After drawing the projector lines, actually we should find all the vertex points, and once we are done finding all the vertex points, we should draw the outermost boundary. After drawing the outermost boundary, the next step is to identify which edges will be visible. For that, we have to watch the diagram from the opposite sides. And then, in this diagram, we see that B and C are first appearing. So the edges from B and C should be visible, and hence they have to be drawn with a dark line. Whereas the edge which is coming from A is hidden behind the face, and hence should be drawn with a dashed line. That's it.
So once you draw the front view, in front view you have to simply draw a pentagon with one of its edge. Here you can see A prime and B prime, or you can say 1 prime or 2 prime. This edge is making an angle of 30 degree with your horizontal plane, that is your reference line XY. Now, how to observe that in top view, that is below your XY line, which are the lines which will be visible? So here you can see this small arrow. So from here you have to carefully observe that from the top, if you will see the line coming from D, it will be visible. Line coming from C, it will be visible. The line from E, again it is open on the upside, so it will be visible. The line from B, it is open from the upside, so it will be visible. Now, the line connecting this A prime and 1 prime, it will not be visible since it is hidden by these surfaces. Okay, so you have to join this A and 1 as a hidden line, or you can say as dash lines. Now see hereafter what to do.
That completes the first bit of the problem. Let us again have a look at the steps that we had seen for drawing the solid. So, as in this step, first we got all the vertex points, then we have drawn outermost boundary with the dark lines, then we identified the inner visible edges and we have drawn them with the dark line, and then we have drawn the remaining edges as hidden. And finally, we had to draw the axis, which in that case we didn't draw because it is not so much necessary. Anyway, you can go on to find the center point of the prism and continue to draw the axis if you wish to do so. Next, we'll go ahead in drawing the second bit of the problem. In the second bit, the angle of inclination of the edge is 60 degrees instead of 30 degrees. So we have to start with the first edge drawn at 60 degrees and continue to complete the pentagon with the steps that we have learned in the previous video. Once the pentagon is ready, we have to get projections of that in the top view. We have to draw all the projectors from all the vertical points or the vertex points, and then continue to get the outermost boundary, identify all the vertex points, and once we have identified all the vertex points, the next step is to view the diagram from the upper.
So here in this second part, can anyone from the class will tell me that in the top view, what are the lines that will not be visible that you have to mark with dash lines or hidden lines? Can anyone tell me? Yeah, we have 33 participants.
Sir, repeat it again, sir. It is not clear.
Here you can see now the pentagonal prism is resting on your vertical plane, which one of its edge is inclined at 60 degree with your horizontal plane. Okay. Now we are going to draw the top view. We have drawn the front view, how it will look alike. Now in top view, the outer boundary we have drawn, as you can see in this figure. Now if the observer, top view means observer is looking from the top side. Okay. Now can you tell me in the top view which are the lines or which are the edges which will not be visible from the top side?
5 and 1.
The line going from 5 to
1, sir.
1 and 1 to 2, sir.
no. Some, okay, you people are correct, but 5 will be connecting to what? Here you can see it is clearly written here 2.
E5.
Yes, E and 5, because see here you have overlapping points. Okay, here at my home I don't have regular hexagon or pentagon, but if I have to show you with one example, I have one textbook with me. Okay, I would like to give you one example. Just I will stop the screen share. Let's see on this video. Okay, I have one textbook in my hand. I hope you all are able to see this. Okay, now this is a box type of, now in that question you have a pentagonal prism. So suppose, let us assume, if I will keep this like the book like this, you are able to see this rectangular face only. Okay, this corner point, someone has pinned the video. Yeah, this corner point and this corner point, I'm tilting to just show you that these corner points are overlapping if you are looking this book from this view. Am I correct or not? In the
Yes,
same,
sir.
in the same way, if you have a pentagonal prism, prism means we have two faces, this face and this is the another face, and those two parallel faces are connected by these vertical lines making a rectangular faces. So since it is a rectangle, so you can say this as a rectangular prism. In that question it is saying pentagonal prism. So there in that question we are having that pentagonal prism. Let me share the screen. Coming back to our slides. Yeah. So here at this point, E and 5 will be connected. So here E and 5, one line will be like this, and that will be hidden. So it will be represented by dash lines. Again, if you are looking at this corners, at this point, that is your point 1 prime or A prime, here you can see that this will not be also visible. If you are see this arrow, this blue color arrow, it is showing from the top. So this point A prime and 1 prime, this is also not visible because it is covering up by these surfaces. So when you connect this A with 1, here they are together, A prime 1 prime, it means some line is there like this, connecting point A and connecting point 1. So that will be hidden. Okay. And C, here C prime and 3 prime, this will be visible because from the top there is no obstruction. So this C and 3 will be clearly visible. I hope you all are able to understand what I am trying to say.
Yes, sir.
Okay, now let's move ahead with this video, how this guy is explaining this.
Inside to identify which of the inner edges are visible. In this case, we see that the point C is the one which is visible. We have to draw that edge as visible with a dark line. The remaining two edges, the one from E and the one from A, are actually hidden behind the faces, and hence they have to be drawn as hidden in the dashed corners. That's it. That is how we draw the pentagonal prism in this problem. This problem was very simple. You can check out the difference between the two diagrams. In the left side, only one of the edges is hidden, while on the right side, there are two edges which are hidden. This has to be identified by watching the diagram in the opposite side as indicated by these two arrows. Yeah, good. This one was very easy to.
So this is what you can see on the left hand side. You can see there is only one line that is hidden. So you, how you can identify which of the edges will be visible and which will be hidden. So you have to see this from the top other part of this front view. Okay. So from the top you have to see which is the face which is hiding if you are looking the object from the top side. And here you have two hidden lines or two hidden edges that is represented by this dash lines. So this is the theory that I have covered for your projection of solids. In projection of solid, in any of these figures that we discussed today, if you have any doubt, feel free to ask me. I'll explain it. And in the next class, that is tomorrow, uh, we will see how to draw this in your AutoCAD software. Now the session is open to all. We have 32 students now. Someone has left, I guess. So if anybody is having any doubt, feel free to ask me. There is a book called Engineering Drawing by Andy Bhatt. If some of you are very curious to learn more about these things, so you can get that PDF of the book. Let me see if I have that book available. I will show you that part also. Graphics book.
Sir, will you share that book in Canvas?
Yeah, I will.
PDF.
Yeah, I will share that. Let me see where is that book. I would like to show you. Yeah, engineering drawing. Yeah, engineering drawing by Andy Bhatt. I hope this is visible to all of you.
Yes, sir.
This book is followed by each and every university in our country. All IITs, all NITs, they are following this book, Engineering Drawing by Andy Bhatt. This is also called as Bible of Engineering Drawing. All the informations or concepts you can get in this book. Suppose you want to study the projection of solids. Where is that? Yeah, projection of solids is there in your chapter number 13. So you can go to this chapter and you can see the type of polyhedra, solid of revolution, and projection of solids in simple position. Then this part, I think it is blurred since I have downloaded it from internet. So maybe I guess they have blurred this page, page number 271. Okay. So in this book, you will be able to see so many components are also there. So uh, if you, with your curiosity, if you want to draw or these figures, you can go for it. It will be very helpful. 271. Yeah. So first projection of planes. Normally, what we follow in conventional methods when we study using your drawing sheet or uh, pencil. So we first teach projection of lines, then projection of planes, and then we come to projection of solids. But here we are uh, clubbing because the demand of the time is those softwares, engineering softwares. So we are clubbing your engineering drawing with your AutoCAD software. So we are teaching you this projection of solid. You can see whatever we have studied in today's class, you can see all the details of that in this book. How to draw the projection. See, this is a pyramid. This is pyramid or prism? Who can tell me?
Pyramid.
Uh,
Pyramid, sir.
can you explain how that this is why you cannot tell this as a prism? Why this is pyramid?
It's having apex.
Yes, very good. You can see here it is having apex. If this is a prism, then you will get one more pentagon at the top surface also. So this is, you can see here also, this is pyramid because all the vertices are getting connected at one point, and that point is called as your apex. So step by step everything is written, how to draw its top view, front view, and in this book the side view is also explained, how to draw the side view. See the cylinder, like we drawn like this. Here the cylinder is placed on your horizontal plane. So this front view is projected like this, and its top view will be a circle that you can see here. And same is explained for your cone also. This is your prism. Okay, here your prism is there, whose sides are equally inclined to your VP. So you can say the vertical faces are equally inclined to your vertical plane. So in that situation, how to draw the projections. So likewise here you will get so many solved example with step-by-step explanation how to draw. See this figure. Here in previous figures, whatever you have seen, here cylinder was resting on horizontal plane, cone was resting on horizontal plane. Here pyramid was also resting on horizontal plane. Horizontal means this plane, and this is your VP means vertical plane. Okay, this is your vertical plane. Now here in this question you can see this is your prism, hexagonal prism, and it is resting on your vertical plane, not on your horizontal plane. So its projections in front view will be like this, a hexagon. Okay, and its uh, top view will be like this. In question it will be even given that it is like 20 mm, or some distance will be given, it is 20 mm above horizontal plane. So this distance you have to maintain, like F and B, this distance, that from here it will be F prime, and the distance from this line XY, so that distance you have to maintain as 20, like that. In some questions they will be given like that. See here, this is 3.5 centimeter above the ground. So this distance, when you will be drawing, you have to keep this 6 prime F prime or F prime E prime 3.5 centimeter above this XY line. So many solved examples are there. So this you can use for your practice. I will upload it in your canvas, this PDF file, and see, we have done only up to this 45-degree. In this textbook, even it is drawn for one more view. So don't get confused with this view. You can confine yourself only up to this part. Okay, but if you want to study in detail, you can go through this. So that's all for today's session from my side. If you have anything to ask, then you can ask, or else I will stop here.
Sir, can you please upload this recording in Canvas?
Today's class is recorded. Yes, it is recorded. I will upload it.
And sir, even that book also, sir.
That book and this slide and the recording, everything you can get in your canvas. Where you can find it, I will tell you. Go to pages, and this is your unit number 4. So I will create one unit number 4. So in unit number 4, I will upload the slide that I have explained today, and I will also upload the video link, that video, today's class recording, and one separate page I will create here as textbook. In that textbook page, when you will click, you will get that ND Bhatt engineering drawing. Okay.
Okay, sir.
Okay, so that's all for today's session. I hope you all enjoyed it, and have a nice day. Stay safe, stay inside. That's all for today's class.
Thank you, sir.
Thank you, sir.
I'm going
Sir,
to
last week video also you not uploaded, sir.
last week recording.
Oh, yes, sir.
Okay, I will check my system and I will upload it.
Okay, sir.